Okay, hi everyone. Hopefully it's working. I've got 7 minutes to do this, and it's 7 mark questions. So let's see if I can do it in 7 minutes. It's not going to be easy. It'll take me ages to sort out the software because things were not working good. Okay, so Izzy Priest asked me this question. Very happy to go through it. We're going to integrate x squared e to the x cubed. Well, firstly, I would point out that if you've ever got to integrate f dash of x e to the f of x, it always integrates to e to the f of x, yeah, plus c. You can just learn that result, but let's say you haven't learned that result, then what you can do is substitution, yeah. So if we use a quick substitution, um, let's go into a slightly different color. Let u equal x cubed here. I want it to be the power on the e, because then du by dx is 3x squared. In other words, a third du is x squared dx. Now, the reason why I've rearranged it like that is because I can see I've got an x squared dx, which I can swap for a third du. And so this then becomes a lovely integral, 1/3 du. Okay, I've swapped out these two, and then it's just e to the u. And so I can see it's going to integrate to a third e to the u plus c, but let's put it back in terms of x. That's going to be a third e to the x cubed plus c. Okay, right, how much longer have I got left? 8 minutes before my year 9 lesson. We can do this. Okay, so getting you to do that first, because that's going to be crucial to getting this bit right. Now, I'm going to use their suggested substitution because I think it's probably the easiest way of doing it. Yeah. So I'm going to start with. Oh, does this not work on that? Oh, yeah, no, it does. Oh, this is getting worse though. I need to clear the board because it always starts stressing out when I haven't cleared the board. Okay, so I've got x to the 8 e to the x cubed dx. I'm going to let u equal x cubed as suggested. And so du by dx is 3x squared. So I'm going to write that as du is 3x squared dx. Now, the way I'm always working with my substitutions is I look and see, have I got a bit of that? Well, I've got an x squared dx hiding in there. So I'm going to write it just like I did before. Third du is x squared dx. And so I'm going to turn this into, okay, now using the by parts formula, I'm going to have uv minus, oh, hang on. I'm sorry, no, I'm using substitution. So let's use the substitution. Okay, I'm going to have, now that's going to become x to 6 e to the x cubed, because the x squared dx, I'm going to swap with a third du. And so if you like, I've now got x to the 6 e to the x cubed, yeah? But I've changed it from dx into du, which is nice, yeah? But what I'd really like to do is put everything in terms of u. Now, if we've got x to the 6, that's clearly going to be u squared, which is x to the 6. So we've got u squared e to the u now, yeah, du. Now, I look at this and I think this is a typical by parts question, and that's why I was mentioning by parts earlier, but it's by parts twice, yeah? And it's really annoying being written in terms of u. So I'm just going to swap all the variables for u for being in terms of x. If you like, I'm making the substitution, let u equal x, if you like. So I'm going back to x. Basically, that's what I'm thinking. I'm just going to go back to, actually, let's not do this. Let's, yeah, it's annoying because we normally have u and dv by dx here. Call it p equals u squared, and normally you have dv by dx, don't we? So I'll have p and q. So I'll have dq by dx equals e to the u, and I'm just trying to avoid awkwardness with the substitution. Okay, dp by du is 2u, and q is e to the u. So I hope you can see that this is normally u and dv by dx, but because I've run out of letters, if you like, I'm having to use this. So, okay, what's this the same as? This is the same as, right, so I'm doing it by parts on this bit. It's the same as pq, u squared e to the u. And it is awkward and frustrating that they've muddled up the variables here. So u squared e to the u minus the integral of q times dp by du. So you're going to have 2u e to the u du. And then we have to use by parts again. So I'm going to let p equal 2u this time. And I'm going to let u dq by dx equal e to the u. So dp by du is 2, and q is e to the u. Okay, what have I got this time? I've got a third u squared e to the u minus the integral of, okay, put this in brackets because you've got to be careful with sign errors here. It's these two terms together, 2u e to the u, minus the integral of q times dp by du. And then I can actually just integrate that directly, and I've got a third u squared e to the u minus 2u e to the u plus, minus becomes a plus, and this just integrates to 2e to the u. Okay, in brackets plus a constant c. And at the very end, let's just change all our u's back for x's. And so what am I going to get? I'm going to get, now remember, u is x cubed in this substitution. So it's substitution with by parts thrown in, which does make it hard. Okay, you're going to have a third x to the 6 e to the x cubed. And then you're going to have minus 2/3 x cubed e to the x cubed plus 2/3 e to the x cubed plus c. Now, is that the format they wanted it in? Let's have a look. They want a third e to the x cubed taken out, which we can do. So let's factorize out a third e to the x cubed, and then we're going to have x to the 6 minus 2x cubed plus 2 plus a constant c. And I think we've got it in their format, and I really hope that's right. Okay, thanks for listening, and yeah, hope that's useful, Issy, and anybody else watching. It's basically annoying because this is in terms of u, and so I've used different letters p and q rather than u and v here. It's otherwise you're going to get baffled, and it is annoying having to use different letters, but if you look in the formula book, they do have the formula. Just swap your u here for a p and your dv by dx here for a dq by dx, and everything, I hope, will make sense. All the best and keep up the hard work. Bye bye.